All right, so I divided you all up with each of you doing one of these. So you're going to just write down the ones that you didn't do, and we're all going to share out our answers. All right, so this is our notation for derivative f prime of x. You're going to get really used to that in this unit. Does anyone remember any of the other notation though? Y prime and just d. We just say dy dx. It's dy over dx. We just say dy dx. All right, what'd you guys get? 3x squared. Good job. All right, group that did the second one, what did you get? That was you guys, right?
Oh, yeah. 2x plus 5.
2x plus 5. Perfect. And then these two groups in the middle, it's 4x minus 3. And then groups over here to this side, 8x plus 5. So here's what I want for you to do. I want you to look at the function and the derivative, the f and the f prime, and see if you can figure out the pattern. The degree is one less, so it does go down. So where did the 8 come from on this one? 2 times 4, the degree drops by 1, and then plus 5. 7 is a constant. -7 is a constant, so that drops out. So what you're going to do is get out your little handy sheet. I'm going to start up here at the top. We're going to do 3 rules today. We're going to kind of cover a lot of ground today. I'm going to use these 3 bubbles. It doesn't really matter. The only thing is you can put them wherever you want. You see this really large one? Save that for the trig. The reason that needs to be larger is how many trig functions are there? 6. Let's name them. Sine, cosine, tangent. But what are the other 3? Good. You guys all took pre-calculus. All right. So save this one for the trig because it's the only one that's going to make that fit. So this is your power rule. And what we're going to write is d dx. What that means is instructions to take a derivative with respect to x. So when it says d dx, that means take the derivative of. And the reason it's called the power rule is because it's for powers. So if you have the derivative of x to the nth, and this is going to look weird because it's n, and everything in math looks weird when it's the general formula, and as soon as you put real numbers into the thing, it makes more sense. But what you're going to do is bring that power down, so the n comes down, and then it would be x to the power n minus 1, so you drop a degree. So now what we're going to do is slide over to the notes and practice that a bunch. It's not that complicated, but when your exponent becomes negative or a fraction, everybody kind of loses their minds. So are we okay with fractions? Are you guys good with your fractions? We're gonna find out. Okay. So f prime equals, all these are gonna say f prime equals. And what you're gonna do is multiply the power down. So what would that give us? Yeah, 12 x to the what? Third. Good. Minus, and then just do the exact same thing with the next one. 12, and now it would be x to the 1. You can write the 1 if you want to. And then what? That's it, because 1 is constant. Constant is a horizontal line. That slope is 0. Okay. Now, I'm not trying to torture you, but if this was multiple choice and they had factored this, could you do a GCF and factor out a 12x? Like the algebra skills are there? Okay. Now this one, we're going to rewrite the problem as x to the what? What's the power for a square root? It is 1/2. Follow-up question, what would it be for a cube root? 1/3, et cetera, et cetera. Okay. Following the same rule, it's just you now have a fraction. So you're going to bring down the power 1/2 and you subtract 1. So it's 1/2 minus 1. What would that give us? -1/2. Good. Now we're going to rewrite that. Here's what I usually do. Draw a fraction bar and you're going to decide what goes where. Now, first of all, it's a 1/2 fraction. So I'm going to put the 1/2 in there. Where does the variable go? Y in the denominator, because it's negative, that takes care of the negative. And because it's a 1/2, it'll be square root. I know that in math, you have to memorize a lot of stuff. And I do understand that when you leave calculus, you go to other classes where you have to memorize a lot of stuff. And then I do understand that outside of school, you have extracurriculars and friends and, a life beyond this where you have to know lots of stuff. But what I always tell everybody is you should probably just memorize that the derivative of square root is 1/2 square root, because you do that a lot and then you won't have to play with the negative halves and like all the fractions. Do you get what I'm saying? Like if you just have that one in your back pocket, you're going to be better off. So derivative of square root is 1/2 square root. And that's why, but I would just memorize that one. This one I'm also going to rewrite before we do the problem. How could I rewrite that function so that it's not a fraction? Well, it's going to be 3x to the something. Good. -5. Good. And then we're going to do the derivative. So you would multiply the exponent down, bring the power down. What would that give us? -15. Now be really careful. It'll be x to the what? Good. Why is it -6? Minus what you're going down. It's becoming more negative. You're subtracting 1. Now we're going to rewrite that. Again, I'm going to draw a line in the sand. We're going to decide what goes where. Where does the -15 go? Well, it's just a coefficient though. So you can think of it as -15/1. The -15 is going to go up top. And then what's going to go in the denominator? Well, x to the 6. Good, perfect. So those negative exponents. So the rule of thumb is your answer should be presented in the same way the question was. So if the question does not have a negative exponent, your answer should not have a negative exponent in general. Okay, but free response, you're allowed to leave it however you want. All right, what do you think about this one? I don't need to rewrite it at all. It's just f of x equals 16/23. Why is it 0? There's no x, it's constant. Derivative of a constant is 0. Constant is a horizontal line, slope is 0. All right, that was power rule. Cool. It's a simple rule. It's just when you get negatives and fractions in there, you have to know your algebra skills. It's not so much a calculus issue as an algebra issue. All right, slide back over to your little organizer. We're gonna do 3 rules today. Your next one is product rule. What does the word product mean? Multiplication. So this is when you're multiplying 2 functions together. So again, d dx is instructions that mean take a derivative. And we're going to have f of x times g of x. Here's what I always tell everybody. Don't get hung up on one being called f and one being called g. On the AP exam, they might call them m and n. Or they might make the first one g and the second one f. Don't get hung up on the letter. In your mind, I want you to think of them as the first thing and the second thing. The letter is not super important, right? The first thing and the second thing. All right, so this derivative is the first thing, so whatever the first function is, times derivative of the second thing, second function, plus the second function times derivative of the first. So it's the first times derivative of the second plus second times derivative of the first. Now, if you were to put these in the other order, would that be okay? Yes, because adding, it doesn't matter which way you add, but try to be consistent because you do have to memorize it. And this is the way I'm always going to write it. So let's try that. Let's slide back over to the examples and we'll try a few of them. What gets hard is trying to identify which rule do I need. So when you look at number 9, do you see how there's 2 separate functions? Like this parenthesis is the first thing And then this is the second thing. Like, do you see that? I kind of can't, I can't go up to you and shake you and be like, do you see it? You know, you kind of just have to do a lot of problems to practice it. All right. This one is going to get very long horizontally. Like you will encroach on the space for number 10. We'll have to do number 10 down here. Just understand that it's going to take up like the whole space. All right. So the way your product rule starts is the first thing. So you're just going to copy down that first function. Like, hey, Miss Cole, it looks like you just rewrote what's there. Sure did. Yep. So the first thing times derivative of the second. Now this one has a negative, so just be really careful. You're going to bring the exponent down. So that just comes down. It'll be -2. And then x to the what? -3. Good. It becomes more negative. Plus, and then what's your derivative of 5x? Good, just 5. Perfect. So first, let me recap what we did so far. First times derivative of the second. You're all still on board? Plus, and then it would be the second function. So just copy that part. And then times the derivative of the first one. So what would we get for the derivative of the first parenthesis thing? 3x squared, good. Plus 7. Cool. If I made you multiply all of that together, you could, but I'm trying to teach you calculus, not algebra, okay? Do you understand if you could like distribute all of these things to each other? Now, to answer like kind of what you were bringing up before, do you see how the problem has a negative exponent? So I'm going to leave my answer with a negative exponent. So that's okay. All right, number 10, I'm going to put below here. Again, going to get large horizontally. So I'm going to ask you guys to walk me through this one. What am I going to write first? Oh, wait, question. Go ahead.
I was just wondering, I'm really not interested now.
Okay, well, we'll see.
Like, so if hypothetically this was ever short answer, like, would it look like that? Or is there going to be like.
You mean multiple choice?
Is there, did I say multiple?
You said short answer.
Oh,
But no, if it was multiple, I've never seen a multiple choice look like that. But usually if they force you to simplify it down, it's not quite that bad.
Okay.
Mostly if they have you simplify, it's factoring. Like it would be something like here, let me show you. What could you factor out of this one? 12x, that would leave you with x squared minus 1. And then how does that split up? That's typically, if they make you go further, what it looks like. It does not typically look like this.
Okay, perfect.
Okay. Because you would have to distribute this x cubed through there and then distribute the 7x and then distribute the negative. Like, do you know what I mean? I've never seen one like that on multiple choice. That's ridiculous. Okay, so you guys walk me through number 10. I feel like some of you probably wrote it while I was answering this question here. What'd you put first? Yeah, the first thing. Good. The first thing. All right, then it's derivative of the second thing. That would give us what? Good. -3. Beautiful. Plus the second thing. Thank you for getting on board with calling it that. Again, you don't want to call them F and G because what if they're not called that on the exam? You know, like be called whatever you want. All right, and then times. Good, that'll be 14x to the 6. Oh, and that's it. Cool. Yeah, I agree. It most certainly is. All right, we'll do one more and then I'll give you your halfway brain break. All right. So f prime equals. Now, before I start this one, do you see how there is a fourth root right there? And I'm going to do some erasing on this one so that I don't have to recopy. Looking around, most people are writing with pencil. If you're writing with pen, that might end up being an issue for you. How would you rewrite fourth root of x? Good. I'm just going to do that. Okay. X to the 1/4. If you're going to do a power rule, it would sure help a lot if there was a power, you know. Okay. And again, this is going to get really long horizontally. We'll have to do question 12 below it, but that's okay. All right. So the first thing times derivative of the second. Now it is a fraction, but the process hasn't changed. Just do the same thing. You're going to bring the 1/4 down, put x, and then you subtract 1. So what would that give you? 1/4 minus 1. Yeah, -3/4. And if your reaction is that's gross, yeah, I'm with you. And then nothing. Good. Parenthesis, just close it. It's not technically wrong. You will never see that though. Like ever, ever, ever. Okay. You want to switch to fractions. All right, plus, and then what's going to come next? The second thing, now I'm going to write fourth root of x minus 1 so that, like, I want it to end up being a root in the end. I don't have to do anything to that one, so I'm going to kind of just leave it alone. All right, and then times derivative of the first, which would be 3x squared, good, plus 2. Oh, I didn't actually run into question 12. Too much. Sorry, this is a fourth root. Mine kind of ran together. Go ahead. I'm just making this look prettier. Wait, say that? Oh, no, but I want to present my answer in the same way the question was given. So since this was a radical, I want my answer to have a radical. So this is what I was saying is I'm going to go back and erase. I'm going to erase this part and fix it. Okay, this 1/4 x to the negative 3/4, I'm going to erase that and fix it. So I'm going to draw my line in the sand. It was a 1/4, so I'm going to keep that. Where would the variable go? Good, because it was negative. Now it was x to the 3/4. That is going to be fourth root of x to the third. That's how you do that 3/4. Now, if you're like, Miss Cole, there's no way I'm going to remember which number goes where. You will. This is how you remember. If it was a fourth root in the problem, it's a fourth root in the answer. That's not fundamentally going to change. So there's only one other spot for the 3. In case you were like, hey, I didn't quite get that, let me just make up another example. Can you give me small numbers, like single digit numbers? Let's do 2/5. How would you write that as a radical? What's that a square root?
Well, 5 on the outside and 2 on the inside.
Fifth root of x squared is how that is done for your information. All right, so go ahead and get out your little rule book here. We're gonna do the third one. We did 3 today. After this, we'll do them one at a time, but these are like the first few are kind of simple, so we can manage to do them all at once. We did product rule. Now we're going to do quotient rule, which this is for multiplication. Quotient rule is for division. So d dx, again, that just means take a derivative with respect to x. When we get into stuff that has time, it'll say d dt. It's like, it's just take a derivative is all that means. And so this is for if you have one function divided by another function, but same thing. I don't want you to think of them as f and g because they could be called something totally different on the exam. I want you to think of them as the numerator and the denominator, kind of like the one we just did. We thought of them as the first thing and the second thing. So the numerator and the denominator. Now this one's going to look complicated when I write it out, but if you remember where it starts, you will get the rest of it. So if you can get the ball rolling, you will get the rest of it. But when I write this out the first time, you guys are going to be like, what in the world is that? All right. So it starts with the denominator. So the denominator times the derivative of the numerator minus the numerator times derivative of the denominator. And I have one more thing to write, but do you see how that's actually pretty similar to the one we just did? Okay, thank you. And then it's over the denominator squared. Now, do you remember how I said for this one, you could interchange these because it's adding, doesn't matter what order you add in. Can you interchange these? No, because when you subtract, it does make a difference. But again, if you get the first part, like if you remember that's the denominator, you will probably get the rest of it. So if you remember where it starts, you should be okay. All right, so let's practice this a few times. So looking at number 12, we're going to write f prime. And you're going to start with the denominator, so 2x minus 1. So again, if you get the ball rolling, if you get the first thing, you will, likely get the rest of it. All right, times derivative of the numerator. So what is your derivative of 3x plus 7? Yeah, just 3, right? Minus the numerator, and then derivative of the denominator would just be what? 2, good, over 2x minus 1 squared. I'm going to pause there and let everybody write it down, and then I'm going to bring up some common mistakes we'll hopefully not make. The common mistake is, do you see how this is 2x minus 1 and 2x minus 1 squared? Those do not cancel. Do not cancel this. No cancellation without factorization. You didn't factor, you can't cancel. Hands off, okay? Now, I am going to actually go a little bit further with this one to simplify it so you can see how it boils down. In the numerator, you would distribute this 3. I'm just going to write right above here. What would that give us? So, yep, just making sure your algebra skills are there. Good. 6x minus 3. In this one, we're going to distribute a 2, but it's actually a negative 2. Good. Thank you for coming with me on that. If you distribute a negative 2 in there, you will get negative 6x minus 14. So what's going to happen there? Yeah, those cancel. Negative 3 and negative 14, negative 17. Very good. And so this is how your simplified answer looks. So like that's the kind of simplification in multiple choice they would kind of add. Do you know what I'm saying? Like that's usually what it looks like. Do not do anything if it is free response for the love of my sanity.
Keep it like that?
Keep it like that. Don't do anything. Like this one, I'll show you. Well, we won't go any further on this one. All right, F prime. How does it start? Denominator. So 5x cubed minus x for the denominator times derivative of the numerator. That would be 2x minus 3. You're getting this fast. You're like catching on really quick. Minus the numerator and then derivative of the denominator would be, good, 15x squared. Oh, wait, there's something else there. Good. Why is it minus 1? Because 1 messes everybody up. 1 is like a complicated number. Yeah, it's x to the 1. Okay, so minus 1. 1 is a complicated number. 1 does mess everybody up. All right, and then it's all over 5x cubed minus x squared. I'm not doing anything else to that. You can if you want to. I'm not. No, thank you. So that's where you would stop. Just write the answer and that's it. All right, 14. How's it going to start? Square root of x. Denominator. Now, what is the derivative of the numerator? It's 1. In the future, I would hope you would skip writing that. For right now, I actually do want you to put it, though, because you're still learning these patterns. Like, I literally just taught it to you. So put it in there so that you know where that came from, all right? Minus the numerator. And then it's derivative of the denominator. Derivative of square root. Thank you for flipping your paper. I want you to just memorize this one because you do it a lot. To square root. Good. If you just know it, it will make your life so much easier. When you get to that, you don't have to mess around with the 1/2 and the negative 1/2 and the fractions and all the things, right? And then it is over the denominator squared. So, good. Cancels. It is just x. Now, I am going to show you how to simplify this one down because I have seen them sometimes do this. So I am going to multiply the numerator and the denominator by square. Actually, I'm going to have to multiply by 2 square root of x. I was going to just do square root of x, and then I realized there was a 2 there. So we're going to multiply the numerator and the denominator by 2 square root of x. So here we're going to distribute it through. So let's multiply it to the first part. 2 square root of x times square root of x. That will actually just be 2x. Good, you guys have good algebra skills. You're there. Square root of x times square root of x is just x. What gets everybody is the algebra. It's not the calculus. Like these rules go well and everybody memorizes them. It's fractions and negative signs and all the distributing and the algebra that messes people up, right? Minus Now, do you see how these are going to cancel and that was the whole point? So it's minus x plus 5 over, now when you multiply this, 2 square root of x times x, does any of that go together? No, it's just we usually put the 2 out front. Now I'm going to go ahead and stop there, but we'll just verbally say, what else could you do with this numerator if you had to? Like, if you had to keep going, you would distribute the negative and then combine like terms. Okay, so I think you said it would actually come out to x minus 5, like if you had to in a multiple choice situation, but I ran out of space, so I'm going to stop. All right, I'm throwing some vocabulary at you. Instantaneous rate of change. What on earth does that mean? Derivative. Thank you. Derivative. I love it. Instantaneous rate of change of that function at 8. Ooh, and then I'm going to show you how to use the calculator. And I have really good news for you. I don't remember if I told you guys this yet or not, but I got an email last week from College Board. You are using Desmos on your exam, not the handheld calculators, because every year I had to teach everyone how to use them. It's a whole bunch of button pushing. It was annoying. Everyone had to buy one and they're over $100. Nope, Desmos, free, and it's built into the exam. College Board did something good. Isn't that crazy? Shouldn't have recorded that. So first thing we're going to do, anyway, I'm going to show you how to do this on the calculator, which is going to be awesome. You're going to love it. All right. So first we're going to rewrite this. It will be 2x. Now that's a cube root right there. How will we write it? It'll be x to the what?
1/3.
Really close.
-1/3.
Good. -1/3 because it's in the denominator. It is a 3. I'm sorry. It printed poorly. I'm sorry. Well, do you want it to be an 8th root? No. Okay. Let's go with cube root then. Two is just a coefficient. 2 is just there. And this is x to the -1/3. 1/3 because it's a cube root and negative because it's in the denominator. Okay. Now we're going to do the derivative. So you're going to multiply the power down. When you do -1/3 times 2, it is -2/3. Again, the calculus is not what gets people. It is fractions and algebra and negative signs, things like that. But do you get what I did? 2 times 1 is 2. There's a negative sign. Okay. I mean, that's what it is. X, and then you have to subtract 1. So it's -1/3 minus 1. Negative, close. I think you said -4/3 is what that is. It's -1/3 minus 1. -1 and 1/3. -4/3. Okay. Now draw your line in the sand. We're going to decide what goes where. -2 goes on the top, 3 goes on the bottom. That's just a coefficient, -2/3. Where does the x go? On the bottom because it's negative. And what type of root is it? It's a cube root. If it's a cube root in the problem, it's going to be a cube root in the answer. And it's cube root of x to the 4th. Good. Perfect. Now, what did it say to plug in? 8. So we're going to plug in 8. See what we get. And then I'll show you on the calculator. All you'll have to do is watch. Now, in case no one ever explained this to you, you do not have to do 8 to the 4th. I'll be really honest. I don't know what that is. 8 times 8 times 8 times 8, whatever that is. You can do the cube root part first and then to the 4th. So what is your cube root of 8? Cube root of 8 is 2. Thank you. 2 to the 4th. Now that's a whole lot easier. 2 times 2 times 2 times 16. So we have -2, 3. I'm going to write it out because if I do too much in our heads, you're not going to see where it came from. Cube root of 8 is 2. 2 to the 4th is 16. Do you know 3 times 16? 48. And then you reduce the fraction, -1/24. All right, watch, because you are going to need to know how to do this. Also, you're really going to like this. I'm going to share my screen. I'm going to come over here to Desmos. You guys have used Desmos before, right?
Oh,
from the they do on the SAT too? Perfect. All right, so I'm going to write f of x equals, what was the function? 2 over cube root of x. And by the way, if you type CBRT, that's cube root, CBRT, or you can go down here and it's like somewhere in functions. I don't know. I just always type CBRT. But do you see how I just typed the function? Now I'm going to come down to the next box and I'm going to type f prime of, what did we plug in? 8. Oh, I wonder if that is what we got. Do you see this little blue fraction bar right here? Is that what we got? Now listen to me. Listen to me. It will do the derivative at 8. It will not do a derivative. It will only do a derivative at a specific number. So don't get all excited and think it's going to do the math for you. It's not. Okay, you still have to like know stuff, but it will do the derivative at a specific number. Okay, 2 more. Write the equation. Ooh, what 2 things do you need to write an equation? Point and slope. It's going to be -1 comma something, and then we'll get our slope. So how do I get the y value? Plug it in. What would that be? -6 over 4. -6 over 4, -3/2. Thank you. Slope comes from, now this is the first time I'm asking you this, but moving forward after today, you're going to hear me say this 4,000 times. What rule do we need? Half the battle is figuring out which rule you need. So which rule do we need for this function? Good. Why quotient? It's division. All right. How does quotient rule start? Denominator. Good. I think some of you are really going to like this unit. It's very cut and dry and boring. Memorize the rules, use them. That's really all it is. All right. Denominator, derivative of the numerator, 6. Good. Minus numerator, derivative of the denominator, 6x over the denominator squared. What are you going to do to that? Nothing. Nothing at all. Leave it alone. Now, what are we going to plug into our derivative? Good. That's your point of tangency. So let's see. That'll be 4 times 6, 24, minus, that would be -6 times -6, so 36 over 4 squared. Did I do that right? 16. 24 minus 36 is -12. And then, so that would reduce to -3/4. Thank you for not saying -0.05. You have all your ingredients? Just put them together. It'll be y plus 3/2, good, equals, this is the one you guys all did pretty well on the test, equals -3/4, parentheses. As a follow-up question, what's an example of a number you could plug in to do an approximation? -1.1 or -0.9. Why numbers like that? They're really close to your point of tangency. Good. All right. And then this is find the 4th derivative. This is what's called higher order derivatives. Remember, I was talking about second derivatives. My class last year, before I could even get the words out, they said prime prime. I've never had anyone say that before in my life, but they shouted it before I could even explain what was going on. And so now it's prime prime. F prime prime is second derivative. But anyway, it just means you do another derivative. That's all it is. All right. So let's find F prime. What would be the derivative of this? 18x squared, good, plus 4x, perfect. So now you're going to do second derivative, f with a double prime, f prime prime, and then you just do the derivative of the derivative. So what's the derivative of this thing? Yeah, 36x plus 4, good. Now we're going to do a third one. Well, what did the directions say, guys? 4th, okay. That'll be 36. Now, when you do 1, 2, and 3, you just put the prime marks. Anything above that, you just start putting the number. No, it's not. It is not f prime 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 prime. But what would that be? 0. And if you have a polynomial, if you go far enough, you will eventually get to 0. Like if you go far enough, it will eventually cycle down to zero.